Hello everyone and welcome back. My name is Mr. Koval, and in this video I'm going to show you how to use molar ratios to convert between elements and compounds. But first, in this video we're going to focus on how to come up with the mole ratio that you can use as a conversion factor to convert between moles and moles of the element that you're interested in and moles of the compound. So let's get into this. So for A, we are asked to write a conversion factor that converts between moles of hydrogen and moles of C2H5OH, which is ethanol. So again, the way we're going to find the mole ratio is to look at the formula itself. The ratio of the particles to themselves is the molar ratio. So for example, here we're asked to find a mole ratio between the hydrogen and moles of this. So if we look at just the formula itself, we want to ask ourselves, well, if we have one of these, then how many hydrogens do we have in the formula? Well, we have 5 here, we have 1 here, so we have a total of 6 hydrogens. So for every one formula unit for this, or molecule in this case, for every one molecule we have 6 hydrogens. Well, that's a 1-to-6 ratio. So one of these to 6 hydrogens. So that is on a particle level, right? One molecule to 6 atoms. One molecule of ethanol gives us 6 atoms of hydrogen. Here they're asking for moles. What is the conversion factor that converts between moles? Well, it's the same ratio. Why? Because if I multiply this by 2, then if I have 6 hydrogens, then if I have 2 of these, then I have a total of 12 hydrogens, 10 of this and 2 of that. So I'm going to have 12. Well, for every 2 of these, I get 12 hydrogens. That's a 2 to 12 ratio. That's still simplified to a 1-to-6 ratio. And so it doesn't matter how many numbers of these I have, it's going to be the same ratio. So if I have 1 mole of these molecules, then I'm going to have 6 moles of hydrogen atoms. So that is the ratio. So the mole ratio comes directly from the ratio between the element itself and the whole formula. So then in this case, the mole ratio is going to be, so for every 1 mole of C2H5OH, I'm going to have 6 moles of hydrogen. And I can flip it. So I could have 6 moles of hydrogen on top and 1 mole of the C2H5OH, the ethanol, on the bottom. So this would be your mole ratio that it would use to convert between moles of one thing and moles of the other. Okay, let's go on to part B. Here they want us to write a conversion factor that converts between moles of oxygen and moles of this substance here. This is our sodium hydrogen carbonate, or bicarbonate if you want to use that name. So here is our formula. Again, we're going to get the ratio from the formula. So we want moles, we want a conversion factor that's going to convert between moles of oxygen and moles of this whole thing. So we need a ratio between this and oxygen. So look at the formula. So for every one of these formula units, how many oxygens do you have? 3. So it's a 1-to-3 ratio. So for every 1 mole of this, I have 3 moles of oxygen. So I write the ratio like I did before. So 1 mole of NaHCO3 over 3 moles of oxygen. Because you can see that every one of these has 3. So if I have 2 of these, then I'll have 6 oxygens. If I have 3 of these, then I'll have 9. If I have 4 of these, then I'm going to have 12. And each of those, the 1 to 3 the 2 to 6, the 3 to 9, those are all 1 to 3 ratios. So even if I have a mole, it's still going to be 1 mole of this to 3 moles of oxygen. And then I can flip it, right? So I can have 3 moles of oxygen on top, and I can have 1 mole of the HCO3 on the bottom. So both of these are conversion factors that you could use. Finally, here we have, we're asked how many moles of hydrogen carbonate ions, so the HCO3 minus, are in 1 mole of the NaHCO3. So here we're not comparing the element to the compound, we're comparing one ion to the compound. So we're looking at this HCO3 ion and say, okay, well, how many moles of this do I have per 1 mole of the whole thing? Well, it's in the formula. So if I have 1 of these formula units, then I have 1 ion, 1 polyatomic ion, hydrogen carbonate ion, right? So there it's a 1-to-1 ratio. So then the conversion factors are either 1 mole of the NaHCO3 to 1 mole of the HCO3 minus ion, or you can flip it. So 1 mole of the hydrogen carbonate ion on the top over 1 mole of the sodium hydrogen carbonate on the bottom. So it's 1 mole to 1 mole. Oops. And that's it. So that's how you can come up with your conversion factors that you can then later use to convert from 1 mole of one substance to another amount of moles to other substances. So that's why we call it the mole ratio. It's used to convert from moles of one substance to moles of a different substance. That's it for this video. I hope you enjoyed the video. If you did, then please like, share, subscribe to my channel. Make sure when you do that you hit the notification bell. And when you do that, make sure you click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. If there's a topic you want me to cover, if there's a particular question or problem you want me to go over, I would love to do that for you. Thanks for joining me and have a great day.